Okay, this might be a slightly longer video, mostly just because I'm doing some explorations with this one, but not too long because I'm planning on leaving within the next 15 minutes. So we have three rectangles that make up a larger rectangle. We have x squared plus 95x plus 450, x squared plus 45x plus 450, and x squared plus 35x plus 300. And so we need to figure out what the dimensions of each rectangle are. These are areas, that's why it's feet squared. So let's go ahead and see if we can factor these out. We have x squared plus 95x plus 450. Remember, the first thing we want to do is take that 450 and see if we can find two factors that will add up to 95. Well, I know that 45 is 9 times 5, and that's sort of like 95, but not. But we need 450, so that would be the same thing as 90 times 5. 90 times 5 is 450. 90 plus 5 is 95. And so this one factors to x plus 90 times x plus 5. X plus 90 times x plus 5. Okay, so we're going to come back to that. Each of these would be in feet. Okay, and maybe we'll see if there's any other ways that we could get 95. I don't think so. We could get 59, but that'd be 59. No, I think that'll work. Okay, we're going to leave it like that. The next one, x squared plus 45x plus 450. I did do some pre-calculations on this one just so that it wouldn't get, let's see, x plus 30 times x plus 15, just so it wouldn't get too long. So 30 times 15 is 450. 30 and 450, and 30 plus 15 is 45. So we have x plus 30 feet and x plus 15 feet. And then the last one, we have 300 and we have 35. So what are numbers that would be? So 30 times 10 is 300, but 30 plus 10 is not 35, that's 40. How about 15 times 20? 15 times 20 is 300. So 15 times 20 is 300. 15 plus 20 is 35. So x plus 15 times x plus 20. Okay, so there's our dimensions, or our those would be, what am I trying to say? Those would be the different dimensions of each rectangle. The two rectangles on the right both have an x plus 15. And I've looked at this, and it's really, I feel like it's not really going to work quite right, but we're going to look at this anyway. This is really as far as we needed to get. We needed to see, okay, this rectangle is x plus 30 by x times x plus 15. This one's x plus 15 by x plus 20. When I'm looking at these, the rectangles have the same width, right? So x plus, let's say this is x plus 15. Well, that should be the same for this bottom rectangle. This part is x plus 15. And so we know that the width should be the same, right? Because, what am I trying to say? Because they have the same, both rectangles have the same width across the top and the bottom. And so it should be the same factor. So that takes care of the x plus 15 part. That would mean that this side right here would be x plus 20. And this side right here would be x plus 30. Okay, this is where things kind of stop making sense. My big rectangle over here, it doesn't have to have the same width as the other one. It doesn't appear to, kind of does in this picture, but not in the real book or in the real problem. But it is skinnier along the top. So let's say that this is x plus 5, and then that would leave us with the x plus 90 for this side. So x plus 90 would go right here. The problem with that is, I don't have a problem with the top, but the problem with the x plus 90 is this side over here should be the same as this side over here, and the x plus 30 and the x plus 20 would be a total of 2x plus 50. That could work. Okay, we'll go with that. I didn't actually think about it that way before. Okay, so 2x plus 50 is this length, which we know has to be the same as the x plus 90. And the reason we're going off of this as being x plus 90 is because it needs to be wider than the x plus 5. Right? X plus 5 is going to be shorter than x plus 90. Okay, so from that, now I guess we have all of our dimensions now. This would also be an x plus 5, and this would also be an x plus 90. So we can actually solve for x. And hopefully you've paused the video and tried this out, but we can actually solve for x. We know that 2x plus 50 has to equal x plus 90. And so if we just do our algebraic expressions, minus 50 from both sides, and minus x from both sides, and then we get x equals 40. And so then we could actually plug everything in, and we could solve for all these areas. We could solve for all these dimensions. Like now we know that this is 45 feet, and this is 55 feet. This is 70 feet. This is 60 feet. 70 and 60 is 130, which, good thing that adds up. This is 130, 45, 55. And then we could also find the areas. And we could find the areas actually by multiplying the 130 by the 45. Or we could go back and plug it in. 40 squared, that's 1,600. 95 times 40, I don't know what that is. 3,600 plus 200, 3,800. Maybe. I'll put this in a calculator later and figure it out. 1,600 would be 4 times that, so 16,000. 16,000 plus 20 plus 2,000, 18,000. Yeah, it's pretty big. Okay, I will actually put it in a calculator to verify my mental math. 1,600, no. 40. 40 times 40 is 1,600 plus 40 times 95. Now, I was way off on that one. That is 5,400. Oh, no, it's not. That's plus. Sorry. 3,800. That was actually correct. If you add the two, that's 5,400. And then plus 450 times 40. No, it's just plus 450. Why am I multiplying things that aren't supposed to be multiplied? That's supposed to be 450. That doesn't change. Plus 450. And so our total area right here is 5,850 square feet. And that had better match 45 times 130. 45 times 130. And it does. So good there. Okay, the other one, 55 times 70 is 3,850. And this one is 60 times 55, which is 3,300. And there you go. And then the area of the whole thing, which we could have added all of our areas up. And originally I wanted to try that, but it ended up not coming out very nicely. I was hoping everything would be divisible by 3, but it wasn't. If we add everything up, then the total area 5850 plus 3,300 plus 3,850, total of 13,000 square feet. That's a good amount. Okay, again, this was just kind of fun to work through and look at. And we saw that we could actually solve for how big the park was based off of these polynomials. And if you ever become a city planner, make sure that you give all of your plans as binomials with the dimensions as binomials, and they have to multiply them out and then solve for x, because that would be fun and they would all love you for that. I'll change my name and phone number so that I don't get any complaints. Okay, that's it for this one.